Now, we just saw enough examples that we felt like we could generalize that the product of complex conjugates is a real number, but we're going to show it works for any numbers, and we can do that by taking this general case. So we're actually going to set up an identity. We're showing that the product A plus BI times A minus BI equals A squared plus B squared. So we're showing it doesn't just work, if a 5 is plugged in or a 2, it works for all real numbers for A and B. So we distribute, and we have A squared minus ABI, and then plus ABI. And here's that kicker that we got to remember. BI times BI is B squared, I squared. And since it's short, I'm just going to copy down the other side. So when I look at this, these cancel. I have A squared. I'm going to actually write out one more step. Minus B squared times -1 for the I squared. And so if I multiply this out, I get A squared plus B squared, and that does equal A squared plus B squared. So just looking back at the problems we did, actually I can't look back, I'm just going to write an example. If I have 2 plus 5i times 2 minus 5i, little crunch there, that's going to be A squared, so 2 squared is 4, plus B squared, so B is 5 here, so plus 25, which is 29. So not only do I know it will be a real number, I know it's going to be the first real number, so the first term, in this case 2 squared is 4, and that coefficient on I, so that's 5. 5 squared is 25, add them together, and that's how it will work. So I'm going to erase this one. The rest of the lesson is just some practice with simplifying with complex numbers. Just applying some of those things we've done, this could really go with Unit 1 if we had known about complex numbers. Here I have a binomial squared, so I have to write it twice. So if I distribute, I have 25 minus 30xi minus 30xi plus 36 x squared I squared, because we have 6xi times 6xi. Both are negative, so it becomes positive. So looking at this, these middle terms don't cancel, and we should expect that because those are not complex conjugates. The signs are the same. So we can combine these. Can make this a -1 down here. So I get 25 minus 60xi. And then this is going to become -36 x squared. Now the directions don't say this, but if I want to write this in A plus BI form, they don't really ask for that with something as complex as this, but technically I should move, this would be my real number. It has 2 terms, but those are both real. And then the 60xi would be that BI term. So not a big deal, you could leave it as the line above, but that's just, if it did ask for that A plus BI form, that's what we would have to do. On the next one, I just have one distribution because if we have a monomial times a binomial. Now I could start out and simplify I cubed and I squared, but since the exponents are small, they're manageable, I'm just going to go straight to distribution, and I can simplify those powers of I at the end. So I get 8i to the 4th, because that's I times I cubed, minus 8i cubed. So I to the 4th is pretty simple to find out. I know 4 goes evenly into 4. So this is equal to I to the 0, which is just 1. I cubed is one of those base powers, so I know that's -I, and I'm going to write -1i, and that always seems to help. So here I have 8 Negative 8 times negative 1i is positive 8i. The last one, we have a cubed, so I'm definitely going to need some space. I'm going to move this over, just create some space for the last one. We do need to write this 3 times in a row. Just to kind of keep that binomial in the front, I'm going to multiply these two together. So that's 4 minus 6i plus 9i squared. This is going to be negative 1. So I'm going to do a bunch in my head just to kind of save space, and because this is a pretty long problem. So this is 4 minus 9 here, right? 9 times negative 1, so that's negative 5. And then this is minus 12i. So we'll bring down the original binomial that we haven't used yet, and then we do have another distribution. So this is going to be negative 10 minus 24i plus 15i, and then plus 36i squared. This becomes a negative 1. So when I combine negative 10 and negative 36, I get negative 46. And when I combine negative 24i with 15i, I get negative 9i. So this is just a combined problem. We're basically going to have two distributions, two sets, right? We have a binomial times a binomial, and then a monomial times a binomial, and then we'll combine like terms. So we're not going to distribute over that plus 4i, right? These are two separate parts. We're going to do this first, and then combine them together. Negative 15 plus 5i minus 6i plus 2i squared for that first part. And then I have 8i plus 12i squared for the second part. Combining like terms and also simplifying these. I'm going to rewrite this, not doing all of the negative ones in my head. I'm going to combine my I to the first together though. So 5i minus 6i is negative 1i, plus 8i is 7i. I have my negative 15. This is going to be negative 2, and this is going to be negative 12. So now those can combine. Negative 15 minus 2 is negative 17, minus 12 is negative 29, plus 7i. Which of the following products would be a real number? So this is kind of going back to what we did on the bottom of the last page, top of this page. If we want to get a purely real number, we need to multiply complex conjugates. So that would be this one. Any of the other ones, those middle terms wouldn't cancel out. So it is choice 3.